What's up, everyone? So today we're going to be talking about Tor. Tor overall has been known for a lot of different things. What's one of the things, though, that it's not really known for? So if you said speed, then you absolutely nailed it. I'm not referring to the type of speed that you find on a darknet market website either. I'm talking about, how fast it actually is. Now, Tor has always been about privacy and anonymity and security. Anyone who's used Tor knows the frustration of, waiting for pages to load. Now, with the creation of POW or proof of work that I cover in this video right here, that got a little bit worse. That was mainly because proof of work essentially demanded that a mathematical problem be solved before the page actually loads in order to make sure that the person who is actually loading the page is not actually an attacker doing a distributed denial of service attack. In any case, that's where Conflux comes in. It's essentially an upgrade to how Tor routes your traffic. Instead of using, just one path through the Tor network, Conflux uses two paths simultaneously. It's like upgrading from a single lane road to a dual lane road for your internet traffic. Now, for that exact reason, it makes this a really big deal. Really, the entire goal of this was to defeat Tor's bottlenecks in terms of things like traffic flow. So how does it actually work in practice, you might ask? Well, I'm glad you did. When you use Tor, your traffic travels through a circuit consisting of three relays: a guard relay that knows your IP address, but not what you're doing or where you're going, a middle relay that knows neither, and an exit relay that can see what websites you're visiting, but it doesn't know who you actually are. This is obviously a very stripped down analysis, but there you have it. So the three relay setup provides excellent privacy and anonymity in contrast to many other networks, but it comes with a cost, and that's speed. Each relay adds latency, and if there, is a relay along your path that is congested or slow, your entire connection suffers. Imagine being, stuck behind a slow truck on a single lane road with no way to pass. It's aggravating. This is especially true when you actually have a goal in mind or someplace to actually be. There are four main concepts that make up how Conflux actually works and why it's actually effective. I won't bother you with the, low-level technical breakdown of each, but let's look at them generally fairly quickly. First is the dual circuit architecture that exists. And this is where, our slow truck analogy comes into play. Conflux establishes two complete circuits instead of just one. One thing that the, truck analogy didn't really cover, though, is that the clever part is that both circuits basically share the same exit relay, but use different guard and middle relays. Now, this means that your traffic reaches the same destination, but can take two different routes to actually get there. Second is the intelligent monitoring system. Conflux consistently measures the performance of each circuit, looking at things like round trip time, which is basically how long it takes for data to make a complete journey, and congestion levels. And that's, basically just checking traffic conditions on both routes in real time. Third comes dynamic traffic distribution. Now, this is based on those measurements that we just talked about. Conflux decides which circuits should carry your data at any given moment. If one circuit becomes slow or congested, Conflux can quickly shift your traffic to the other circuit. And this isn't just, switching paths. In some cases, Conflux can actually use both paths simultaneously for pieces of data. The fourth component is the reordering mechanism. Now, when you send data through two different paths, it might arrive out of order. Makes sense, right? Conflux handles this by adding sequence numbers to keep track of the correct order, then reassembling everything properly at the actual destination. Now, think about, how you might handle a large group of people traveling between two cities. In the traditional Tor approach, everyone would just pile onto the same road, traveling as one massive convoy. And if there's congestion or construction or an accident or heavy traffic or someone gets a flat tire, like everyone gets delayed. Now, with Conflux, you could split your group between two different roads. You might send the faster vehicles on one road and the slower ones on another. Or if you discover one road is, getting congested, you could immediately redirect some of those vehicles to the other road. And by the time everyone actually reaches their destination, you've literally arrived way faster overall than if everyone took the same route. Now, when two circuits first connect under Conflux, they go through a handshake process. Basically, an introduction where both sides say, I'm here and ready to work together. This happens through a series of messages passed back and forth that establish the relationship and measure how fast each path actually is. It's not unlike when you first connect to any secure website where your browser and the server exchange information before the actual communication begins. So we get to the point of why Conflux matters for everyday users. Why should the average Tor user care about this at all? The most immediate benefit, obviously, is speed. By using two circuits and, intelligently routing traffic, Conflux can significantly reduce the time it actually takes to load websites or download files. For people using Tor in their daily lives, this could be the difference between a frustrating experience, and a usable one. Like imagine waiting 30 seconds for a single web page to load versus waiting, 5 to 10 seconds. It's, the difference adds up over time and definitely affects whether people actually even want to use Tor. Now, reliability is another huge benefit. With traditional Tor, if your circuit experiences problems, your connection might drop entirely. With Conflux, if one circuit has issues, your traffic can shift to the other circuit without interruptions. And this means, fewer disconnections and a more stable browsing experience for everyone. Beyond the speed improvements, Conflux may also offer some things like security benefits. Some research suggests that splitting traffic across multiple paths could make certain types of traffic analysis more difficult for adversaries. When your traffic travels through a single path, an adversary who controls, parts of that path can potentially observe patterns in your traffic. So by splitting traffic across two different paths, you're making it harder for any single observer to see the complete traffic pattern. However, it's also important to note that, Conflux isn't primarily designed as a security enhancement, right? Its main goal is improving performance, while obviously maintaining Tor's existing security properties. Now, aside from the potential security challenges, there are also some other considerations that really need to be considered when moving forward. One additional concern with Conflux's implementation is memory usage. Like when data arrives out of order through two circuits, it needs to be temporarily stored until it can be reassembled in the correct order. And this creates what's called a, out of order queue. And that consumes memory on Tor relays. I'd be curious to know if any of you think that this could end up being a much bigger issue in the future, potentially even an attack vector of some kind. Let me know in the comments below. Pause it and let me know. Okay, so now that we got that out of the way, Conflux does actually include a few mechanisms to limit memory usage, including low memory variants of its scheduling algorithms and safety measures to prevent potential denial of service attacks that could exploit these very queues. Now, I know when I learned about, out of order queue, this was basically my main concern. Right off the bat, hearing that additional computational power may be needed was like, oh, that might be a problem. Now, Tor uses a mechanism similar to TCP's congestion control to try to prevent any single circuit from overwhelming the network. Transition out of this kind of nerd speak, basically. Congestion control is Tor's traffic management system. Just like how, a highway on-ramps sometimes, have traffic lights to prevent everyone from merging at once during rush hour. Tor uses congestion control to prevent any single user from overwhelming the network. So, like when a circuit gets congested, meaning it's carrying too much data, Tor automatically slows down how much information is sent through that particular circuit. Conflux, with this system, works well. It applies these controls to each circuit completely independently. Now, this is actually one of Conflux's really big advantages. If one circuit becomes congested, it can shift, traffic to the other circuit like we talked about before. But this is instead of slowing it down. So it's like being able to switch to a less congested lane of traffic when it all backs up. One concern with Conflux is also the potential for, what are called side channel attacks. And these aren't obviously direct attacks on encryption itself, but more of, an attempt to learn information by observing patterns in how the system actually behaves. So off the top of my head, one example could be in a different context, all of the information that you're sending is encrypted. However, I know you have a meeting and, when it potentially will be thanks to metadata. So I don't actually need to know specifically what the other party and you are saying in that specific conversation or instance. So another scenario, for example, would be if someone couldn't read your actual mail, but could figure out who you were communicating with just by watching when you actually visit the mailbox and how many letters you may send. In Tor's case, side channel attacks might reveal relationships between circuits that should have remained private. However, Conflux actually addresses these concerns as well with a careful design choice. For example, it includes limits on how often circuits can switch between others and validation checks to ensure that malicious relays can't manipulate the linking process. The system also includes network-wide settings that can be adjusted quickly. And, this includes an emergency off switch that could disable Conflux entirely if things like unexpected issues arise in the network. Now, this leads to a discussion on consensus parameters. And don't worry, they're not as complicated or boring as they actually sound. The Tor network has a built-in voting system where all major relays participate in deciding network-wide settings. And these are the consensus parameters. That's it, right? So think of it like rules of the road that everyone agrees to follow, and every hour or, whatever, the relays vote on these parameters. And once they reach an agreement, every relay and client follows these rules. So for Conflux, these parameters include things like how many paired circuits you can have, how often you can actually create new ones, and even, that emergency shutoff switch that we talked about earlier. The system ensures that if something goes wrong with Conflux, the Tor developers can quickly adjust or even temporarily kill it network-wide without needing everyone to actually update their software. So let's zoom out for a while, mainly because I think we've covered a lot of intricate details, moving away from the microverse and into the macroverse, if you will. You might consider what Conflux means for the Tor network as a whole. If widely adopted, Conflux could lead to a more balanced circuit distribution across the entire network by using 2 circuits per connection, which would spread traffic more evenly throughout the network, if nothing else. Improved performance could also attract more Tor users. Many people want things like privacy or anonymity, but really aren't willing to sacrifice too much speed to actually get it. It's fairly understandable. If Conflux can reduce that trade-off, it might expand the actual Tor user base. Who cares? Well, more users would increase the overall anonymity of the actual network. Remember, with Tor, a large user base means better anonymity for everyone because it's harder to distinguish between the actual users. So, what about the users? Which ones would actually benefit from this? Well, different types of Tor users might benefit from Conflux in different ways. So, answering that particular question would be kind of complex, but for casual users who just want to access the web privately, the speed improvements would make the experience much more pleasant, provided, lame sites didn't destroy their accounts because they use Tor. Just a friendly reminder, any site that, doesn't allow you to use Tor should immediately be something you're leery of. It's like going into a jeweler and then flipping out because you brought in a device to test the authenticity of the jewels you're about to buy. That's kind of an issue. Now, for users in censored regions who rely on Tor to access blocked content, Conflux could make this access much more reliable and responsive, potentially making a really big difference in their ability to get information or disseminate it. Journalists and activists who use Tor for sensitive communications might appreciate both the improved performance and the potential additional protection against certain types of traffic analysis, in addition to the potential for better overall security due to the fact that, we may see an increase in the Tor user base to begin with. This last point alone is an additional really big one for the darknet market users that are out there. All of this is great, but the real question is, where does Conflux stand right now? Well, there's a proposal that exists, and I'll link to it in the description. It's number 329, and it has the title Traffic Splitting. It's also almost 5 years old. It was written way back in 2020 by David Golet, sorry if I mispronounced your name, dude, and Michael Perry. The proposal describes a really well-developed design that's being implemented and tested, from my understanding, currently. Even though I've known about this for some time, I've hesitated to actually discuss it in detail, mainly because you don't actually know if it's going to be implemented. It's a proposal. It wasn't something that traditionally was really mentioned too much on Tor's website. So I was very excited to see it in a recent blog post on the Tor project, talking about how Arti, which is basically just a Tor client coded in Rust. And again, for those of you that are not familiar, I don't mean coded as in covered, but rather as in programming. And I don't mean Rust as in iron oxide, but rather the programming language that exists. Arti is a whole different video that I'm not going to do, right now, but in the blog post, they have a fleeting mention of Conflux. I have to confess that, when I saw this in the release of Arti that they were mentioning, where they said they're starting to lay the groundwork for full implementation of Conflux, it was 8 p.m. at night. I was by myself in a dark room surrounded by monitors. And I was like, nice. So that's how that went down, if you really wanted to know. It should be interesting to see this implemented on a large scale. It should also be interesting to see the response. And, I don't mean just the response from individuals like me or you, but also the response from various threat actors, right? Like seeing if we see some new attacks in the wild will definitely be interesting moving forward with this new implementation. Now, Conflux is designed with future improvements to Tor, including the potential for things like UDP transport mechanisms that could further enhance performance for real-time applications like, voice calls, stuff like that, which would be, it would be absolutely nuts. I think that this proposal is an absolute winner. It seems to check off the box that for a while has not been checked, which is speed. They've also managed, by virtue, basically, of how Tor works, to make it more secure in like the same brushstroke. Making Tor more usable is absolutely massive. Conflux could be the upgrade that makes Tor practical for everyday use for those people. And the beauty of Conflux is that, like, it doesn't require users to make any trade-offs, right? Like, you don't have to choose between better performance and security, and you don't need to go learn a bunch of stuff in order to use it. It just works right out the box by default, and in the background. So that's the thing I'm really, really excited about, is to see like the network, expand like with that speed in mind. That's going to be really, really, really interesting to see. And obviously we'll also have the reverse will be true. Just like Medico puts out a new lock, by the end of the year, someone's picked that new unpickable lock. It'll be the same thing. It'll be interesting seeing the back and forth that exists between those threat actors and the Tor project. So after 5 years, I would be really amped to see this come to light. In any case, thank you for watching to the end. And as always, I'll see you in the next video.